Hello everyone, System Chalk here for part 7. So this is the third video for week 4 of our Roguelike Dev does the complete roguelike tutorial. So just clarify, I'm sure probably at this point this is not news to anybody, but there is a subreddit called our RoguelikeDev, and they have an annual event. I think it's been going on for about 8 years or so, where they will go through a tutorial called the Complete Roguelike Tutorial. Now, I actually don't know who is responsible for this, but it's obvious that from what we saw in a previous episode, that they were updating the tutorial as the event was going by. This particular one is a little older, but it still holds up. Obviously, we've only had some minor updates in terms of some adjustments that we can make. Yeah, so as I was saying, it does a once a week cadence. Now, I actually find this very fun to follow. And then it's also kind of nice just to have a little bit in the bank, just in case I get busy. My goal for myself has been I'll have sort of a definite cutoff, but if I can get things done ahead of time, I want to see maybe what extensions that I can do, or maybe just resolve any side issues, or just generally try and do a little bit more with the project. So we are now on week 4, which begins Tuesday, July the 30th. You will, of course, see at the top of the screen that it's a couple of days before that. But I think I had more than a week before, so I'm actually losing time. But if you want to start now, I believe you still can, but it ends on August 27th. So there's about a month left if you are looking to take part in the event. I've certainly found it worthwhile. And the other thing that's nice about this community, so I was sort of aware of it before. I think I found one of the participants who does a game called Cogmind on Twitch through this. Oh, actually, this developer right here. So Cogmind isn't made using any of the tools inside of this tutorial, but it does sort of seem to be something where the subreddit doesn't just necessarily follow this tutorial in the sense of using Python and the Python version of Tcod. There's lots of different projects that people are doing. I notice a lot of Rust, but not exclusively Rust by any stretch of the imagination. I am also not the only one doing the original Python tutorial. But because it is a subreddit, there's actually a ton of other tutorials here. So I don't really feel anybody should be doing the Python 2 one at this point. But it does look like there is some variation on this one for both C++ and Rust. It's worth remembering that I believe this would be the library that, like the original Tcod library, would be compatible with C and C++. Looks like there's a few different Rust variations. C# obviously very popular. I don't know if it's really fair to just say C# if you're doing Unity, because yes, you can build components using C# in Unity, but obviously C# is intended for something to be doing your own programs with. So the one thing that I think would actually be kind of interesting if I were to try something completely new, and I'm not entirely sure I am skilled enough or that there's enough value for it, but I actually think it would be interesting to see a Swift version of this, because certainly development on Mac OS is a thing, and Swift is... I actually have a chat with this with my just somebody I meet at the local game dev meetups, and I have sort of this prejudice against languages that make things easy. So, I like using Python because it helps me with the data stuff. And then I'm sort of like, okay, well, if you need the speed, then you use NumPy. And then, if you really need it and you don't have inside of, NumPy, then you have to learn the dark arts of, C or Fortran or something like that. But I've always had this imagination that, there's the division between something that's sort of nice and friendly to use like Python. And then, if you want to do something sort of speedy or something, something nice, something maybe that would be a little more fundamental, or something that would, I'm trying to think of the right terms here, but basically you'd use Rust if you're sort of modern and interesting, or, C, C++ if you're, if you like the old ways. But this actually isn't entirely true. We talk about how, really Swift does actually seem to do quite a bit and seems to work very well, and that maybe you don't need to say, oh, because it's easy to use, it isn't good for doing big or ambitious projects with. Now, again, I am not somebody who does big and ambitious projects, so I'm not really in a position to say that for sure. But I guess the biggest one for me is I notice the way that I think about these things as opposed to how I do, like how I compared to what I know from actual experience. And definitely I sort of have this I just kind of assume that good software or hardcore things need to be hard. And there's absolutely no reason to think that that is true, right? It's kind of like saying, I don't know, writing has to be difficult, or, painting, if you're not mixing your own pigments, it's not real painting because Leonardo did it that way. Like, obviously there are improvements, and we should hope that it becomes easier to do things, because that's what technological progress is, and that's what has increased our standard of living over a long enough time period. But we need to finish our first run through this. So on to part 7. Now, I was feeling definitely very groggy at the end of the last video, so I took a little bit of a break. I've had a nice big glass of water. I have a tea sitting in front of me. So we should be able to get through creating the interface in one go. Part 7, creating the interface. Our game is looking more and more more playable by the chapter, but before we move forward with the gameplay, we ought to take a moment and focus on how the project looks. Despite what some roguelike traditionalists may tell you, a good UI goes a long way. One of the first things we can do is define a file that will hold our RGB colors. We've just been hard coding them up until now, but it would be nice if they were all in one place and then imported when needed, so that we could easily update them if need be. Create a new file called misspelledcolor.py and fill it in with the following. When in Rome, though, so. All right, I do not know these values by heart, so I'm sure some people are just thinking in terms of code, but I'm just gonna slavishly follow 0x, E0, 0x, E0. XFF, XFF, nope. Player die. Need die. Okay, bar text. So I can't put that in the parentheses because then that would be, I think that would count as a tuple. I'm actually not sure. I think it would count as a tuple. I can't remember if this would cause a problem or not. I think it would, but bar filled. I wonder if they call this bar filled, if this is going to be a bar for HP. Bar empty. 0x10. Okay, so I mean, again, there's a little bit of an argument here that it's probably more efficient just to copy and paste, because I'm sort of slavishly just placing these values in, but I don't know. Probably it's good for me to just get more practice typing, particularly on projects like this where I'm not using them in a notebook. Some of these colors, like welcome text and bar filled, are things that we haven't added yet, but don't worry, we'll utilize them by the end of the chapter. Last chapter, we implemented a basic HP tracker for the player with the promise that we would revisit in this chapter to make it look better, and now the time has come. We'll create a bar that will gradually decrease as the player loses HP. This will help the player visualize how much HP is remaining. To do this, we'll create a generic render bar function which can accept different values and change the bar's length based on the current value and the maximum value we give to it. To house the new function, as well as some of the other functions that are coming soon, let's create a new file called renderfunctions.py. Okay, so renderfunctions.py. Our old friend future, import annotations from typing, import type checking, import color, which is the one that we just invented. If type checking, we need to import tcod, import console. So remember, we're putting this inside of int because remember how we talked about how you'd think that with a double slash you would be able to get that truncated value, but it turns out that if you do have a float as one of the argument, or actually I guess in this case it would have to be because there's definitely a float here. But anyways, we're forcing it into an int for bar width. Draw a rectangle. That's interesting here. Okay, so if we do console dot I'm thinking that some of my features are not working properly because I feel like the whole point of type hinting is that I should be accessing all of the methods available here. All right. So from the names, this should be kind of clear, right? That we have the empty bar, which is originally overlaid. If we have anything in that bar, we then draw the filled values on top of it. It's actually kind of interesting to see the hard-coded values here because I remember one thing I sort of struggled with when I was playing around with a couple of Unity tutorials was the UI elements are very sensibly designed to have sort of these positions almost as sort of like a percentage of the screen, right? So clearly nowadays we have lots of different monitors, lots of different resolutions. And this is not even accounting for some of the stranger things that you can run into, like ultra wide monitors. And there's a whole thing, if you look on some games, you'll see complaints about the fact that, you know, the game may or may not be compatible with an ultra wide monitor. And so, you know, what do you do in a case like that, right? How do you, you definitely can't just say, here's the universal value, you know, it's definitely going to be in coordinate 045 for all monitors because that could be radically different for every, you know, every other player. So in in that case, the challenge is that it can also be really weird to just sort of think in those terms. And in some cases, you do want to have certain parts of the UI. So for instance, I would assume if you're playing a game on an ultra-wide monitor, you probably do not want to have vital information in the very bottom left-hand corner and the very top right-hand corner. You probably want that to be in sort of a fixed area so that, you can sort of glance over. But that involves a sort of a degree of understanding of what the player needs and wants at a given point of time, and then on top of that, an appreciation of what the different monitors, what the different resolutions are going to be. And presumably the way that you do that is not to just brute force through every possible iteration, even if you're just looking at it in a tiny little window as like a little mock-up. You're definitely not going to buy all the individual monitors to check that. But in this case here, we're sort of lucky. We've decided the window size, and the window size is one that could be run on any given monitor. But that is an interesting challenge to sort of think of here in terms of if we were doing it in Unity and we wanted to follow the Unity way of doing things, how would we want to draw the limits of the bar? So print, okay, we've got x1, y45, string. Oh, nice. So I think this is still printing the HP value. I was going to say if it didn't do this, I was going to actually write this, see if I could write this on top, but it looks like they're actually giving the written value we had before. Okay. We're utilizing the drawRect functions provided by tcod to draw rectangular bars. We're actually drawing two bars, one on top of the other. The first one will be the background color, which in the case of our health bar will be a red color. The second one goes on top and is green. The one on top will gradually decrease as the player drops hit points, as its max value is determined, as its width is determined by the bar width variable, which is itself determined by the current value over the maximum value. We also print the HP value over the bar so the player knows the exact number. In order to utilize this new function, make the following changes to engine.py. So this would be under render. So just add the render bar and get rid of console print. Okay, run the project now, and you should have a functioning health bar. Render bar is not defined because I didn't import it. Looks good. We will, well, let's do our usual thing of running through the dungeon and clearing everything out. Okay, dark red, nice to see. If I run into a couple more trolls, this is not going to go well for me, but we made it. It's kind of interesting. I wonder how much sort of planning went into this particular HP value and the attack values for the different enemies, because generally it feels like it's survivable, but definitely we've wound up in a couple of times where there's just too many trolls and we we can't realistically expect to complete the dungeon. In any case, doing my usual bash into some walls, hit escape, and we're good. Doesn't seem to have any errors. Color looks a little different. Actually, I'm just going to run this one more time. So if I compare it to this, right, this definitely looks more vibrant than... Of course, I wind up with empty rooms. Oh, here we are. Right, like generally that just looks quite a bit dimmer than the alternative. I might take a second here just to make sure that the value isn't the value is not. I'm sure it's not, but let's okay, filled is 0, 60, 0, empty 40, 10, 0. Oh, there nope, 40, 10, 10. Okay. What next? One obvious problem with our project at the moment is that the messages get printed to the terminal rather than showing up in the actual game. We can fix that by adding a message log, which can display messages along with different colors for a bit of flash. Create a new file called messagelog.py and put the following contents inside. So one of the tells that Rough is behaving a bit differently is I remember it used to tell me off for doing print statements. It's sort of like, you know, in sort of proper projects, you know, normally you log your errors rather than print them. And I'm like, I know, but it's good to have those kinds of, those bits of advice, right? Like this is why you have software to sort of tell you when stuff is going wrong. But that's just kind of an indication to me that things aren't running the way I sort of wanted them to. And I should care about this, right? I should try and see if I can restore things to the way that that they were. Anyway, oops. From typing, import list reversible. That's a new one. Tuple. Import text wrap. So text wrap in this case looks like it's a Python module. I've never encountered that one before. Class message. Okay, init. Self text. Tuple. Presumably that's the color. Oh, this is interesting. So if it has a count, I would imagine that maybe this is just telling you, you know, 4 times that the troll attacks the player for this rather than just sort of spamming the log. I wonder if that's how that works. All right, full text. Okay. This, I think, is fairly sensible, right? Message log, it's a list of messages. Add message, self text, which is a string. Color. I'm not quite sure what FG stands for, but maybe foreground. Excuse me. Sorry again. Again, sorry. Okay, if stack is true, then the message can stack with a previous message of the same text. Okay, so this should hopefully be self-explanatory. If we've enabled stack and the text of the message and the previous message are the same, then we increment the count, which presumably will just, the way we'll see that in the log is, 4 times instead of 3 times or whatever. Excuse me. If not, and we just add it to the log. Okay. That is fascinating. Oh, okay, yes. Okay. Static method. Let's see what this says. Convert a function to be a static method. A static method does not receive an implicit first argument. To declare a static method, use this idiom. Static methods in Python are similar to those found in Java or C++. For more, I wish I could make this bigger. For more advanced concepts, see class method built in. So I have a little bit of an idea about how this works. So I'm not 100% sure why that what this does here. Again, I don't think it's done for no reason. It's just I don't have a firm enough command of this idea. Let's maybe take the idea of addition. So addition's a little bit of a tricky one just because that's like an operation that you can already do in the language. But let's just say for the sake of the argument that you wanted to do some function that had addition or something. Now the concept of addition, the concept of adding 2 numbers, doesn't really need to live with your like that particular instance of a number, right? The definition of adding 2 numbers is just sort of this broader concept that it is its own thing. It's not dependent on what class is being run. And there are some problems with this, right? Because technically the plus sign operator is actually defined for things other than integers. you know, if you, for instance, if you take two lists and you put a plus between them, that is in fact defined inside of Python. But just for the sake of the argument, let's say that we're talking about numbers like we learned them in school. At least the earlier schools, I realize even numbers themselves can become weird and wonderful things. But the idea for the static method here would be that this is just something that sort of exists independent of the specific class, which is why, unlike all of these other ones, it shouldn't have a self. And I think that was mentioned in the. Now this is much easier to read. Still has the same text though. And I imagine in this case, if we're rendering the messages, I guess it's because we want the messages to come like from only one place. We'll see. Else, I may actually be interested to see what the description says that this does. But so def render messages. We'll sorry, just a minute here. That gets a comma at the end. Okay, so I think this makes sense here that the messages are rendered starting at the last message and working back. We'll see it in action, but offset height. I think there are some data structures that actually would allow you to sort of work. Like you could sort of design it in such a way that that reversal is sort of automatic, but I think probably it makes sense. It would make more sense to just work with the messages in a common sense way. And then when you have a structure in which you're storing the messages, then the display part does the display. So in this case, you're saying, okay, show them in reverse order. That just seems to be a lot easier to keep in your head than having some unusual data structure that sort of puts that reversal in place, especially if you just want to change it in the future. So for message in reversed, messages, line in reversed, text wrap, message, full text. So I'm trying to understand what this second reversal is about. Print x is x, y is y plus y, offset, string line, message g, y offset minus equals 1, less than 0, return, no more space to print messages. Okay, let's just see if I can, we're going to get to the commentary in just a little bit, but I'd like to see if I can make sense of this on my own. So, first of all, I spelled reversed wrong. So, we take a message in messages for each line in... Okay, first of all, we'll say each message in here, we take the full text and the width. So we call wrap on this, wrap a single paragraph of text returning a list of wrapped lines, reformat the okay, I think I get it here. So because there may be more than one line in reverse, this is still following the convention that we've set. So console print, we have the X and Y position plus the Y offset. The string is the line, message is the foreground. Y offset minus one, hang on. Right, because we're printing this one line at a time. If we only do the one line, then we're back to message. If the Y offset is less than 0, then we get out of that. Okay, this makes a little more sense to me. I'm not quite sure how it handles once the sort of the list of messages gets too long, but I'm sure we'll see that in a minute. The message will be used to save and display. Oh, actually, no, that won't matter because you just stop rendering them because you're doing them in reverse order. You just stop rendering them when you run out of space because who cares, right? Those are old messages. The message will be used to save and display messages in our log. It includes 3 pieces of information. Plain text, the actual message text, foreground, color of the message. Now we know what FG means. Count is used to display something like the orc attacks 3 times rather than crowding our message log with the same message over and over. We can stack the messages by increasing a message's count. This only happens when the same message appears several times in a row. The full text property returns the text with its count. Actually, this it occurred to me one thing that becomes a little challenging here is if you're fighting 2 monsters at one time, because then the log winds up getting crowded quite quickly, just because presumably they're each going to take their turn and those are going to be different each time. But maybe let's just not fight monsters 2 at a time. The message log, the full text property returns the text with its count if the count is greater than 1. Otherwise, it just returns the message as is. Now, the actual message log. It keeps a list of the messages received, nothing too complex here. Add message is what adds the message to the log. The text is required, but the foreground will just default to white if nothing is given. Stack tells us whether to stack the messages or not, which allows us to disable this behavior if desired. And if we are allowing stacking, and the added message matches the previous message, we just increment the previous message's count by 1. If it's not a match, then we add it to the list. And then finally this one here. This render calls render messages, which is a static method that actually renders the messages to the screen. It renders them in reverse order to make it appear that the messages are scrolling in an upwards direction. We use the text wrap function to wrap the text to fit within the given area, and then print each line to the console. We can only print so many messages to the console, however, so if the Y offset reaches -1, we stop. To utilize the message log, we'll first need to add it to the engine class. Modify engine.py like this. Okay, so after input handlers from message log import render, message log. Under init, we need to add the message log. Obviously here I enabled a couple of other plugins, so it's going to be making some adjustments to the program, but I'm actually okay with that. We're adding an instance of message log to the initializer and rendering the log in the engine's render method. Nothing too complicated here. We need to make a small change to main.py in order to actually make room for our message log. We can also add a friendly welcome message here. I am all for friendly welcome messages. So before engine, import color, good God. Map width, so we're shaving off 3 from the map height. And then after update FOV, engine message log, add message, Hello and welcome to yet another dungeon. Feel free to experiment with different window and map sizes if you like. Run the project and you should see the welcome message. All right. Well, let's fix this first. Hopefully that takes care of all of them. I'm actually going to escape out and then see if... Much better. Hello and welcome, adventurer, to yet another dungeon. So no messages yet in terms of the orcs. Again, just trying to bang into walls. I'm not going to complete the whole dungeon unless we can get it done really quick. Cool. Now that we've confirmed our message log accepts and displays messages, we'll need to replace all of our previous print statements to push messages to the log instead. Let's start with our attack action in actions.py. Okay, so start with importing color. Then where are we? Ooh. So I'm doing this in a virtual machine, so occasionally I scroll off to the other window and get surprised. All right, I think this is where I want to be. So damage, self, entity, fighter, power, target, fighter, defense. Yep, so instead of the... No, before the script, if self entity is self engine player, okay. So remove the print, engine message log, add message. I should have saved the text, but that's fine. Okay. Else self.engine message log, add message. All right, we determined the color based on who is doing the attacking. Other than that, there's nothing really new here. We're just pushing those messages to the log rather than printing them. Now we need to update our death messages. Open up the fighter.py file and modify it like this. I don't think we have fighter.py open now. No. So again, we go, nope. Port color. I think we just changed the print. Okay, nope, there's one other thing we changed, color. Message color. then self engine message log, add message, add the death message, and then the death message color. Run the project now. You should see messages for both attacks and deaths. Now this is one where I'm going to want to make sure that the character dies as well. Well, we're starting off with a troll, so I might get what I want. So great little opportunity here to see some of the text working as well. Lots of different colors. I will confess, I am sort of looking at this on the other monitor and sort of looking over a microphone and stuff like that. This is a really interesting hallway. Who died? Okay. No, nothing like yelling at me, nothing to make me feel bad. Looks like the sort of stacking of messages is working out here. It actually also occurred to me that if there are lots of enemies with different attack types, that might also be a problem. Although interestingly enough, I guess that does seem like it's stacking these up after all. I should maybe think a little bit about how that message log works a bit better. I will just say in general, it's a little tricky for me to keep an eye on what's going on inside of that message log, but that's also because I'm not as focused. I'm sure if I were to play it over here, that would be fine. But overall, seems like it's, oh, escape action self engine player. Oh, because it's capital S. I wonder how many times that snuck by without me paying attention. That definitely was in one of the commits. Let's do this real quick. That's more like it. Okay. What next? One thing that would be nice is to see the names of the different entities. This will become useful later on if you decide to add more enemy types. It's easy enough to remember orc and troll, but most roguelikes have a wide variety of enemies, so it's helpful to know what each letter on the screen means. We can accomplish this by displaying the names of entities that are currently under the player's mouse. Oh, I wasn't even thinking that there would be a mouse interaction. That's neat. We can accomplish this by displaying the names of the entities that are currently under the player's mouse. We'll need to make a few changes to our project to capture the mouse's current position, however. Edit main.py like this. So under root console, right here. Nope. Root console, console, screen width. No, this is it. Screen width, screen height, order F. While true, root console clear, engine event handler on. Interesting. Event handler on render isn't defined. At least in terms of the autocomplete. Get rid of engine render and engine event handle events context. Okay. We're adding the console's clear back to main as well as the contents present. Also, we're calling a method that we haven't defined yet on render. Okay, that makes sense, but don't worry, we'll define it in a moment. Basically, this method tells the engine to render. We're also passing the context to handle events now, because we need to call an extra method on it to capture mouse input. Now let's modify input handlers to contain the methods that we're calling in main.py. So handle event self is getting changed. I walked right by it, didn't I? Handle events. Well, that's game over handler. We need event handler. There we go. Okay, so this needs self context, tcod context, still none. No longer throwing not implemented for event in tcod event wait context convert event self dispatch event. EV quit is still the same, and we now add on render. It's also fair to say that this is, I previously made an analogy to an interface. This definitely would not, the analogy to an interface isn't really appropriate here anymore because we're obviously implementing some steps in here. So I think that would be an abstract class in this case. Again, Python is my strongest. And because you now have several videos seeing me with Python, that should tell you how much I know about other languages, let alone Python. Okay, so apparently I've been doing this wrong. I need to be adding more white space between things. My bad. Main game event handler is also changing, so we need to add a context for that. For event and tcod event wait, we still have action, but context convert. Oop. And finally, game over handler. Again, we change the handle events. But I don't think there's anything material that we change on the inside there. Okay. We're modifying the handle events method in event handler to actually have an implementation. It iterates through events and uses context convert event to give the event knowledge on the mouse position. It then dispatches that event to be handled like normal. OnRender just tells the engine class to call its render method using the given console. Main game event handler and game over event handler have small changes to their handle events methods to match the signature of event handler, and main game event handler also uses context convert event. We're no longer passing the context to the engine class's render method. So let's change the method now. I'm assuming this is an engine. Okay. You're out. You're out. And you're out. We've also removed the console clear call as that's being handled by main.py. So we're passing the context around to different classes and converting the events to capture the mouse location. But where does that information actually get stored? Let's add a data point onto the engine class to hold that information. Add the following to engine.py. Well, we're already in there, so we've got engine game map under the init self mouse location tuple 00. So presumably starting in the top left-hand corner here. Okay, so we've got a place to store the mouse location, but where do we actually get that information? There's an easy way by overriding a method in event handler, which is called evMouseMotion. By doing that, we can write the mouse location to the engine for access later. Here's how that looks. I don't remember if we have that open or not. Init handle events. hang on. Yeah, event handler, handle events. Def ev mouse motion self event tcod event motion none self engine game map is in bounds. Oh, that's interesting. We haven't called that in a while. Tile X, tile Y, self engine mouse location equals event tile X, event tile Y. Great, now we're saving the mouse's location, so it's time to actually make use of it. Our original goal was to display the entity names that are in the mouse's current position. The hard part is already done. Now all we need to do is check which entities are in the given location, get their names, and print them out to the screen. Now, of course, this is where the earlier steps really help us, because we already have a bunch of functions defined to say, hey, get me that thing at that tile here. And looks like we've already, we just wrote the function that will get us the tile that the mouse is hovering over. So, since this has to do with rendering, let's put the new functions in renderfunctions.py. After color, so we need to import engine and game map first. From engine, import engine. From game map, import game map. And we're defining this before render bar. So def get names at location. X is the X coordinate. It's an integer. Y int. Game map is a game map. Presumably so that we can call the function not map in bounds X, Y, or not game map. Why? That's an interest. I would never have thought to include visible, but that's obviously important. Turn blank. Entity name for entity in game entities if entity X and entity Y. That's interesting. We're basically doing the same thing that we would normally do to find an entity, but in this case we didn't actually use the get me that entity at position XY that we used before. I'm not 100% sure on the function, but I would have thought that we actually would take advantage of the I would have thought we would have taken advantage of the function that we wrote for that already. Okay. Turn names capitalize. There we go. And then after render bar, def render names at mouse location. Console X coordinate, Y coordinate, engine is an engine. Return none. So pull the XY coordinate out of the mouse out of the engine. Names at mouse. You're kidding me. We just defined this. Okay, fair enough. Did I just mess up the name or something? Oh no, sorry, we're defining something here. That's right. So get names at mouse location is, or at locations. Mouse X, Y, mouse Y. Okay, and then we need to actually put this thing in the console. There we go. We've added two new functions, render names at mouse location and get names at location. Sorry, one second here. Actually making decent time compared to what I thought we would. Okay. Sorry, we've added 2 new functions, render names at mouse location and get names at location. Let's discuss what each one does. Render names at mouse location takes the console, X and Y coordinates, the location to draw the names, and the engine. From the engine, it grabs the mouse's current X and Y positions and passes them to get names at location, which we can assume for the moment will return the list of entity names we want. Once we have these entity names as a string, we can print that string to the given X and Y location on the screen with console.print. GetNames at location also takes X and Y variables, though these represent a spot on the map. We first check that the X and Y coordinates are within the map and that they are currently visible to the player. If they are, then we create a string of the entity names at that spot separated by a comma. We then return that string, adding capitalize to make sure the first letter in the string is capitalized. Now all we need to do is modify engine.py to import these functions and utilize them in the render method. Make the following modifications. I also wonder, so I know there's an idea of sort of the game ticking every frame or something like that, so I'm assuming that it's not sort of constantly polling the mouse's location. So, it's like getting the same XY coordinate like 10,000 times a second or something like that. But I'm not quite sure what TCOD does in the background to set that. That might be something worth checking out in between sessions. Okay, so after message log, actually, no, we're just adding to render bar, render names at mouse location. Then we go after render bar in render. Console, X at 21, Y at 44, just taking the game's or the tutorial's words for it here, and the engine is itself. Now, if you hover your mouse over an entity, you'll see its name. If you stack a few corpses up, you'll notice that it prints a list of names. So let's check that out. As much as I enjoy running around the dungeon, it's actually also good for double checking that there isn't anything too weird that's happened, because I'm sure you've noticed I'm rather good at adding typos. Okay, come with me, my friend. Nope. All right, so there's an orc, there's a player, there's the remains of an orc, orc and the remains of an orc, 2 remains of an orc, and now a player. Oh, here's an interesting question. So I think this will, I don't think I should see a name here, but okay. So I'm going to head back. All right, so I shouldn't see any indication of an orc in here, and that's exactly what happens. Cool. No complaints either. We're almost finished with the chapter. Before we wrap up, let's revisit our message log for a moment. One issue with it is that we can't see messages that are too far back. However, hexadecimal, so just a note here that this is the maintainer, contributor, I'm not quite sure what their official title is. I think a maintainer of the Python TCOD library. So thank you for not only maintaining that and answering my question, but also helping the tutorial. However, hexadecimal was kind enough to provide a method for viewing the whole log with the ability to scroll. Excuse me. Add the following to input_handlers.py. So I've got the game over event handler. All right. Oh God, key sim, I think. Let me make sure I've got that right. Yeah, key sim. What am I doing? Okay, -1, tcod event, key sim, down 1. It's 10. Okay. Reviewer event handler. So inherit from engine. Okay, so we're defining the log length as the length of messages, and the cursor, one cursor minus the log length minus 1. Def on render self console tcod console to none. On render console, draw the main state as the background. Sure would have helped if I put the comment there. Log console, capital C. Actually, there's a console.console. Yep. That's why yeah, so I keep correcting it to capital C, but it's actually trying to tell me what the proper version is. Okay, so log console tcod console.console console. Let me spell it right. -6 console height -6. Log console. So obviously a lot of these are just sort of introducing some new functions that, I mean, I think from context, like these are all well named, right? So when we say something like print box, I don't think there's any surprise in terms of what's going to, my God, what character is that? I don't think there's going to be any like surprises in terms of what that does, but it does make it a little bit hard for me to commentate just because I'm learning at this point. All right, there's the alignment. So render the message log using the cursor parameter. Self engine message log render messages. My God. Great. So in the cursor here, I'm taking this, like, I don't think this is taking it as like a mouse pointer or something like that, but rather sort of the cursor in terms of a, like a Word document. And then log console blit. Okay, log. I have absolutely no idea what that does. Blit this console onto the desk. Yeah, I don't know what blit means. I think at this point I'm just taking the tutorial's word for it. That is a lot of code for me to try and keep track of. Okay. Curious if we can use pattern matching in here, but it's matching multiple values. A player may be able to drop multiple items using a series of commands: drop key, drop sword, drop cheese. This interface might be cumbersome, and you might like to allow dropping multiple items in a single command. Not quite. Incidentally, matching objects, I feel like, was one of the ones that I needed earlier. I feel like you should be able to match against something in a list. So even if most commands have an action object form, you might want to have user commands of different lengths. For example, you may want to add single verbs with no object. Okay, right. So we have a single verb, single object, but that's not quite what we're looking for. Matching specific values, we've got these here. This looks promising. So this is one of several. You know, I'm wondering. Yeah, so there's a small challenge that I have here, which is I can see why the ors work. But I think if we were to take cursor Y keys, so one of these 4, I don't think this would work the way that we want it to. But let's see if it works. I'm also wondering if we can maybe just take a look at the, okay, 634, structural pattern matching. Is there like an index? Probably not. Maybe mapping? I wonder if it's possible to just say in, so like the thing to remember for me is that it's saying that this is equal, so we've got the split, right? That this is equal to a single item inside here. Or we've got like a literal. So it's testing. So yeah, so like the thing I would say is like what I'd sort of want would be in cursor Y, but I don't think that works. But let's just say cursor. This is just pure experimentation at this point. I suspect this is not going to work, but I'm curious. Okay. Okay. To show this new view, we will need all we need to do is this in main game event handler. Now again, I'm expecting this is not going to work the first time. Wait a minute. Main game event handler. Right, on key down. Okay. Okay, so we push the V button to get the history viewer. Let's see if that works. No. Name capture cursor Y keys makes remaining patterns unreachable. Interesting. Let's do something even more basic. Sure, info world. Let's see what we've got. This is the tutorial all over again. I'm getting mad. Okay, match against a collection with at least one value. The other values, if there are any, are stored in values. Not what I needed, though. This is just probably the wrong tool for the job, I'm guessing. Boolean might be interesting. Okay, no, true or false is not interesting. So this is tempting here, right? In the context of pattern matching, only the following are recognized as sequences: arrays, collections, lists, memory views, ranges, tuples. So the thing is that it would not be that hard for me to convert. It wouldn't be that hard for me to convert Y keys into its keys, right? That's keys from the dictionary. That would give me a list, I believe. Okay, sequence patterns are patterns with comma-separated values enclosed within parentheses or square brackets, depending on whether or not the sequence pattern contains a wildcard It could be a fixed length or variable length sequence pattern. The fixed length sequence pattern has to match the subject lengthwise and element-wise. Not good then. Patterns of the key could be literal or value patterns. All or some of the keys in the mapping data structure could be specified. If only some of the keys are specified, other keys are ignored and the pattern will match a key. Okay, nope, that's still not what I want. So I think it would be fair to say that this is the problem that I think, like I said at the start, this is not the right tool for the job. I'm misusing pattern matching in this case, which is good. I mean, again, sometimes a little disappointing when you find a cool new toy and I'm not using it properly, but it's nice to sort of see why I might have been misguided. I'm sorry to just delete all of that. I'll it's less than 0. And self cursor. Nope. Keep getting this wrong. Key sim, right. Okay, after all that, I think we're ready to give this a try. So first of all, try the basics, run in troll. Okay, so clearly we've got more than our, clearly we have more than the original log. So now I press V. No! History viewer does not have a cursor. That's in line 141 of input handlers. Let's Doesn't like self cursor minus log length 1. Okay, history viewer. Okay, so that's in the init. Right, I'm trying to subtract rather than define. That's kind of a big problem. I think we have enough for a log, but let's just go into another room and... Okay, that was a little faster than I was expecting, but... All right. Mouse overs are still working. Just make sure the rest is okay. Cool. I need a lot more messages. Also, we have some... future warnings soon. The tcod module will no longer hold constants directly. Add from tcod import libtcod copy if you haven't already. Okay, we'll do that now. Sorry, tcod pi. Replace tcod center with, okay. It'd help if I did that on the right screen. Okay, you know what? Let's get out of the tutorial and see if we can... Oh, wild. Had another rapscallion. Okay, so in this case, I don't think I need to worry too much about the... in this case, I think we'll just go through the whole dungeon and try to queue up a whole bunch of events. Oh. Oh, it doesn't let us... Interesting. Okay, couple problems here. So number one, I can't read the log after I die, and that feels... Well, I mean, I guess the information in terms of the... like, my final moments were there, but I don't know, it might be nice to be able to see the whole thing. But looks like... this event's tile coordinates are uninitialized. You must pass this event to context convert event before you can read this tile's attributes. If self game engine map in bounds... Since input handler 61... I confess I'm a little perplexed by this one. So I'm going to go run around the dungeon and try to cause some trouble. Preferably not dying this time. So if I run into an orc, I'm okay with that. I can get 2 whacks in, but if it's something bigger... Oh! No! I don't think there's any way that I can trigger any more events. Uh-oh. Yeah. Fascinating. So something is happening. This is definitely going to be one that I make a note for. So something's happening when I die to change the initialization. And it feels like it's just a random tile. It's like one of the not visible ones. But it's definitely messing with my ability to... like I can't see anything on the tile here. But it's actually proving kind of elusive to get a full... Okay. Again, I'm going to run through the whole dungeon trying to cause trouble. This time I'm kind of going to play to win. If I run past an orc and they do some damage to me, so be it. Oop. Okay, I gotta get out of here. Still not enough. All right, well, you know what? Let's... I'm actually also curious, when I push V, I want to see if that troll gets closer. But right now, I just want to see if the log does what it says it does. So up, down, page up, and page down. Well, that's interesting. Oh, so it just cycles through. Fair enough. Home. Okay. End. And anything else returns to the game. Okay. I'm dead. Now, I'm curious here. So notice in the terminal, nothing's shown up yet. So as soon as I jiggle the mouse, yep. Does not like the tile coordinates being uninitialized. So I'm going to need to follow that. I don't see a lot of value in messing around with this on the video, especially because this probably could have been shorter, and I went down a bit of a rabbit hole in terms of the structural pattern matching, but that's going to be my homework over the course of the next week. I'm going to see if I can figure out what's happening with the uninitialized tile coordinates. If you want to see the code so far in its entirety, click here. Click to move to the next part. So we're going to get items in inventory and quick refactors. Once again, apologize to everybody reading this now. After publishing the last 2 parts, there were once again a few refactors on code written in those parts, like at the beginning of the part 6. Luckily, the changes are less extensive. So we've got some AI, static methods, entities, nothing really to address the mouse over. Okay. So I think what I'm going to do, on my own time, I'm going to double check the code that I have against what is in the repository. I think that's a good first place to start. Then I'll have a little bit of a think in terms of why specifically line 61 has the trouble that it's currently having. But I think we've done enough work for tonight. Thank you everybody for hanging out, and I will see you for next week's episodes 8 and 9. These do look to be somewhat sizable, so it might be one video for each one. Well, I don't know. It's about a quarter of it is refactoring, and the refactors aren't that extensive, so maybe we'll get lucky. But yeah, probably my homework will be figuring out what happened with that mouse over and seeing if I can fix it. All right, thanks for watching. We will see you in the next one.